Hi everyone, I'm Jackie, and today in this video, I'll be going over the geometry and trig questions that appeared on the June 2024 SAT exam. So, per usual, let's just jump right into it. Okay, so first things first. Here in triangle PQR, the measure of angle P is 3x plus 5 degrees, the measure of angle Q is 2x plus 9 degrees, and the measure of angle R is 4y plus 5 degrees. If side QR is extended through point R to point S, and the measure of angle PRS is x plus y degrees, what is the value of x plus y? Okay, so always for geometry questions, draw them out to help give yourself a visual. You do get scrap paper on the SAT, so this would be 3x plus 5, Q, it's 2x plus 9, and we know that R is 4y plus 5. Okay, and then it says that side QR is extended through to point S, so this goes down here, and we'll say that this is our point S. And then this angle, PRS, so the PRS pertains to this angle, and this angle is x plus y. Okay, so definitely it appears that I'll need to create a system of equations. So first, I know a triangle has 180 degrees. So I'm going to first sum P, Q, and R. So do 3x plus 5 plus 2x plus 9 plus 4y plus 5. And then combine all the like terms. So combining the x's, that'd be 5x, 5 plus 9, so plus 19. Plus 4y equals 180 degrees. Now subtract the 19 from 180. So I'm left with 5x plus 4y is equal to 161. Next, I know that this is x plus y, so look here. Yes, I'll put in red. So from here, I have a straight line, right? So I know that the sum of these two angles, 4y plus 5, as well as x plus y, angle PRS, is going to also sum to 180 degrees because it's on a straight line. Straight lines are 180 degrees. And again, I'm going to combine like terms. So for this one, I would have 5y plus x. I'm going to just move the 5 to the other side. So it's equal to 175. Okay, and then from here, I have two system of equations, and then I can simply solve for x or y. So let's go ahead and do that. Okay, I'm going to do this one. I'm going to say that x is equal to 175 minus 5y. And then I can go ahead and substitute this in for x up here. Okay, so let's do that. So this would be 5 times 175 minus 5y plus 4y is equal to 161. Now distribute the 5. So 5 times 175, that's 875. And 5 times 5 is minus 25y. And plus 4y equals 161. Combine the y, so I'm left with 875. Minus 21y is equal to 161. Subtract the 875 from each side. So I would have negative 21y is equal to negative 714. Now divide each side by negative 21, and I get that y is equal to positive 34. Okay, and now I know what y is equal to, so I can just go back to any one of the equations. Let's go back to 5y plus x. That is equal to 175. I'm going to now substitute in the y, that is 34. And then we can get our x value. So 5 times 34, that is, is 170. So I have 170 plus x equals 175. Subtract 170 from each side. X is equal to 5. And remember, we are asked for the value of x plus y. So x plus y is going to be x is 5 plus 34, and that is equal to 39. And that is what I would type into the answer sheet. Okay, so that one was amazing. Oh my goodness. What do we have here? A circle equation. Okay, so circles, they're part of geometry. This would be more coordinate geometry, but I wanted to show you the amount of questions that have appeared on the exam. Okay, so this one we have a circle in the xy plane has a diameter with endpoints a11 and AD, where a and d are constants. An equation of the circle is x minus a squared plus y minus 17 squared equals r squared, where r is a positive constant. What is the value of d? Okay, so first, if you're not familiar with the circle equation, make sure you get yourselves familiar with it. So it's always x minus h squared plus y minus k squared is equal to radius squared. That is a k. So h and k, they always stand for the center coordinates of the circle, and r stands for radius. The radius of the circle. So here I can see that the center coordinates of the circle, it is positive a and positive 17. And I also have endpoints of the circle, so I know a11 and ad. Okay, so let's think about this. We can just simply solve this one, but I just want to give you a little bit of a visual here. So I know that the center's at somewhere on x, and 17 is my y value. So let's just say, we'll say this a value's here, and my 17 is up here. So that would be the center. And then the other one I have at a11, my other provided coordinate. So that would go down. This is at 17. So we'll say it's around here. I'm just eyeballing for learning purposes. Okay, so I have a11 and a17, and I'm asked for the value of AD. Okay, so important. If I'm to get the other value of D, I know that this distance from the center to the other endpoint, that's the radius. So I also know that the distance D that I'm looking for, it's also going to be whatever the radius is. So we'll be somewhere up here, will be AD. Okay, so this will be the radius. So I do know that taking the two endpoints, if I do D plus 11, dividing by 2, that's going to give me the center value of 17. So I can use that. So let's set that up. 11 plus D divided by 2, halfway point, is equal to 17. Next, I can multiply each side by 2. So I would get 11 plus D is equal to 34. And then I can subtract 11 from each side, and I get that D is equal to 23. So this would be a 23. Isn't that amazing? So just remember for this one that the center of a circle, it's always going to be the midpoint of the endpoints of the diameter. So in this case, our diameter was D and 11. Those are the two endpoints. So I know the center will be the midpoint, which is why I use this equation. Okay, amazing. Let's continue our journey. My goodness. So circle A has a radius of 2x and circle B has a radius of 94x. The area of circle B is how many times the area of circle A? Okay, so, well, this one, we know that the area of a circle, it's always expressed by area equals pi r squared, r for radius. So first I want to calculate the area of circle A. So let's do that. So circle A, it says it has a radius of 2x, so area equals pi 2x squared. And important, when you are distributing the exponent, make sure that you distribute it to the 2 and to the x. So this will become just 4x squared pi. So that's the area of circle A. And then we should do the same for circle B. So same exact approach, area is equal to pi 94x squared. And then I'm going to distribute the x, or sorry, the square, but make sure you are distributing to both 94 and to the x, just like we did in the previous one. So hold on, 94 times 94, it is, 8,836 x squared. So I have my two areas, and my next step will be to determine how many times the area of circle B is how many times the area of circle A. So all I'm really going to do is put them over each other. So the area of circle B, 8836 pi x squared over 4 pi x squared. And then we can see that these will nicely cancel. And then I basically just have to do 8,836 divided by 4. And that will give me that it is 2,209 times bigger. And that's the answer. It's a simple one, but these are the questions that appeared. Okay. Oh, look, up next we have trig. Okay, so here, triangle XYZ is shown as a right triangle. Which of the following has the same value as sine of x? Okay, so first you should know SOHCAHTOA. SOHCAHTOA. Okay, so looking at sine, that's opposite. I will just write this here for anyone new to trig. Opposite over hypotenuse. And if I'm asked for sine of x, so the opposite would be 37. So I'll put sine of x equals 37. And I have to calculate what the hypotenuse is. So let me go ahead and do that. I can do that by doing 29 squared plus 37 squared is equal to c squared. Let's calculate. Okay, so 29 times 29, it's 841, and 37 squared is 1,369 is equal to c squared. So I have 2210 is equal to c squared. And then final step is that I need to take the square root. And so the square root of this is not pretty. It is 47.01. Well, it's like 0.063. It's a non-terminating decimal, but that's okay. So we'll say this is 47.01. So this is 47.01. And I'm looking for the answer that will provide me the same. So let's look at the choices. I mean, just looking at this, it's going to be cosine of y. And I know that through theorem that since these two angles, both x and y, they're complementary angles, it's always true then that sine of x will be equal to the cosine of y. It's the sine and cosine relationship, which basically was this like sine 90 minus x. This is a theorem that you can know for the exam is equal to cosine of x, and likewise cosine 90 minus x is equal to sine of x. So I know from there, but just to prove that I am true, or it is correct, if I do cosine of y, cosine is adjacent over hypotenuse. And if I look at y, it's going to be adjacent 37 over 47.1. So I've just proven that to be true. And if you try all the other ones, like if I did cosine of x, that is 29 over 47.01. That doesn't work. Tan of y, that would be 29 over 37, so it doesn't work. And tan of x would be, it's 37 over 29. Okay, so therefore it is indeed cosine of y. But really it's just testing this amazing trigonomic identity. Okay, and then continuing, triangle inequality theorem. So in this problem, it's actually nice because they tell you what the triangle inequality theorem is. However, I always tell my students you should know it anyways, just in case they aren't as nice and don't provide what it is. So the triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the length of the third side. Okay, so think of a triangle, imagine three sides. The sum of two sides must be greater than the third side. That's English translated into math. So if a triangle has a side, lengths 8 and 13, so let's label this 8 and this 13, which inequality represents the possible lengths x of the third side of the triangle. Okay, so I can always calculate the range with the triangle inequality theorem by simply summing the two sides provided. So we'll do 13 plus 8, which is 21. So that would be my extreme end. And then I would also do 13 minus 8, which is 5. And so when I know this, then I know that angle Z, for example, would have to fall in between. It must be greater than 5, but also less than 21 for it to be a triangle. And oh my goodness, can you look at this? Well, they asked for X, I called it Z. Same thing, it matches option C. And just to prove why that would be true, so for example, if I did put 5 in for Z, that doesn't work, right? Because 8 plus 5 greater than 13. No, that's not true. Um, but 5.1 would be, or if I did 6, it would be. I hope that makes sense. But know the triangle inequality theorem for the exam in case that they don't give this introductory sentence. I'm actually surprised that they did do that. Okay, and then continuing, we have a couple others. Amazing. So the table gives the perimeters of similar triangles TUV and XYZ, where TU corresponds to XY, and the length of TU is 6. Okay, amazing. And I'm asked for what is the length of XY. So let's see. Okay, well, let's just draw this out for visual purposes. So if I have triangle TUV, and then I also have triangle XYZ. Okay, and then it tells me that TU is 6. So if they're similar, I know that TU is going to correlate to XY. I also know TV is going to correlate to XZ. And I also know that UV is going to correlate to side YZ. Okay, amazing. So I'm asked for the length of XY. Okay, so similar triangles, the ratio of the perimeters of the triangles is equal to the ratio of the corresponding sides. Important, take note of that. So therefore I can just set, for example, like triangle XYZ and triangle TUV. And then I could say that will be equal to length XY. And then this would be equal to the length of EU, which was given. And now I just need to substitute all the values that they've given us. So I know X, Y, Z, it's 150. So 150. XY is what I'm solving for. TUV, it's 50. And I also was given that TU is 6. And now I just cross multiply. So we'll do 150 times 6. 900 is equal to 50XY. And then divide each side by 50, which is 18. And oh my goodness, that looks like an answer choice C. Do-do-do. Okay, so remember, similar triangles, the ratio of the perimeters of the triangles is equal to the ratio of the corresponding sides. And that's how you can solve that one. Okay, so this one, we have in the figure AC is equal to CD. Important piece of information. So just label that. So AC is equal to CD, which means that this triangle is isosceles. So remember that in triangles, the sides are always opposite to their corresponding angles. So this corresponds to this angle, which will be the same, and this corresponds to this angle, which will be the same. So my pink angles are going to be the same. Okay, so then we also are provided that EBC is equal to 29. And we also know that ACD is equal to 108 degrees. Okay. What is the value of x? So, well, first, hmm, I would first just do 180 minus 108, which is 72. And then I would divide by 2 because I know that these angles are the same because it is an isosceles triangle. So each of these are 36 degrees. Okay, but still not enough to give me what x is. No problem. So also I can go here and I can do, again, 180 minus 108. This one, it's going to be 72 degrees because it's on a straight line. And then I can do 72 plus 29, which is 101, and then oh, minus 180 minus 101, which is 79. And then here, these are vertical angles here. So this would be 79 and 79. Vertical angles are always congruent or equal to each other. And then finally, I would do 79 plus 36. And then, which is 115, and then do 180 minus 115. And let's see what that is. Oh my goodness, it's 65 degrees. And that would be the value of x. But, in the sheet, or not the sheet, in the computer, I would type 65. Oh my goodness, wasn't that amazing? Okay. Oh my goodness. So you might be thinking to yourself, this is a lot of geometry questions for one SAT exam. These are from various SAT exams from June, but from different countries. So you get a little feel of all the areas of the world. Okay, so let's see. I'm giving this shape. Looks like, well, let's see what it says in the figure. NP is the diameter of semicircle O. Angles Q, R, and S are right angles. Okay, Q, R, S, right angles. And point P is the midpoint of NQ. Okay, so PQ is equal to 52. Okay. And NS is equal to 18 feet. Okay. The area of the figure can be expressed as a pi plus b square feet, where a and b are integers. What is the value of a minus b? Okay, so first, let's see. I would know just that this is also 18. And then the next thing I would do, all right, so I know that point P is the midpoint of NQ, which means that this whole length would also be 52, which would mean that the radius of the semicircle is 26. So let me put this is 26 and this is 26. Okay. And then next I can calculate then the area of the semicircle. Let's do that. So the area would just be pi r squared, but divided by 2 because it's half of a circle. And then I can do that. Area is equal to pi. The radius is 26, 26 squared, and then we will divide by 2. So let's calculate. 26 times 26, 676 divided by 2. So the area of the semicircle is 338 pi. Okay, so next up on our agenda. Okay, then next we can calculate the area of the rectangle. So remember, this is 52 plus 52. So this is 104. So rectangle would just be 104 times 18. And that is equal to 1872. And it says that the area of the figure can be expressed as a pi plus b, and this would be 338 pi plus 1872. And then I'm asked, what is the value of a minus b? Okay, so my a value correlates to 338, and my b value corresponds to 872. And final step, would be 338 minus 1872, which is equal to negative 1,534. And that would be, the answer that I type in. You can type in negative numbers. Okay, so guys, those were some questions that have appeared on the geometry and trig related, the June 24 SAT. I would be familiar with similar concepts because they tend to repeat very similar concepts on every exam. So make sure you know these ones for the exam. And I hope this was useful. And if you liked the video, enjoyed it, found it helpful, like and subscribe to the channel. And I'll see you in the next video. All right, bye guys.